Actually, two inclined planes are given. Both are kind of identical, but one plane is smooth, the other plane is rough, and the angles of inclination are 45 degree. And a block is kept on this inclined plane, and this travels through a distance d in a time t. But to cover the same distance d on this rough inclined plane, it takes n time t seconds. If that is the case, what is the coefficient of friction between the block and the surface? That's the question. Suppose if it slides on a smooth inclined plane, we know that downward force is mg, and this is mg cos theta, and this is mg sin theta. Since friction is not there, the downward force is mg sin theta. So mg sin theta is the downward force. Force is equal to mass into acceleration. Then we know that the downward acceleration here along the inclined plane is g sin theta. Let us assume that in the inclined plane it covers a distance d. Then we know that from this relation s is equal to ut plus half at square. Displacement along the incline is d and slides down, so initial velocity is 0, equal to half. The acceleration along the incline is g sin theta, and the displacement along the incline is d, so it is d square. Okay, so sorry, the time taken here is t square. But here in this case, this block, when it slides down, because it is a rough plane, the frictional force will act in the opposite direction. The downward force is mg sin theta anyway, but the frictional force is mu times normal reaction. So the normal reaction n here, if you look at, n will be equal to mg cos theta. So it will be mu mg cos theta. Then the net downward force equal to mass of the object into acceleration. Net downward force is mg sin theta minus mu mg cos theta. Then in this case, if you cancel out the m's, you know the net acceleration is equal to g sin theta minus mu g cos theta. Then they say that the time here is n times the t seconds. Here if you apply the same, the displacement d equal to ut plus half at square, as in this case ut is 0, so it is half a. In the second case is g sin theta minus mu g cos theta, half a t square. Here n times t, the time it takes, so t square. So since they slide through the same distance in both the cases, the left hand sides are equal, and hence the right hand sides must be equal. So half g sin theta t square is equal to half g sin theta minus mu g cos theta into n square t square. So half g can be taken out and cancelled, and t square and t square will be cancelled. So it is sin theta. Here the angle of inclination is 45 degree. So sin 45 degree equal to sin 45 degree minus mu cos 45 degree into n square. Sin 45 degree 1 by root 2. So this is sin 45 degree 1 by root 2 minus mu times 1 by root 2 into n square. So when you multiply all this, so root 2's will be cancelled. 1 is equal to 1 minus mu into n square. So it is 1 minus mu equal to 1 by n square, and mu equal to 1 minus 1 by n square, or n square minus 1 by n square.